Welcome to today's program. I'm Angelo Lampusis from the Department of Earth and Atmospheric Sciences at City College of New York, interviewing today my colleague, same department, Assistant Professor Stephen Kidder. Professor Kidder, Steve, welcome to the program.
Thanks. Nice to be here.
So I was reviewing before coming in your entry at the annual report of the Division of Science, recording your various achievements. It was a concise entry, but very telling of your experiences so far. And there's obviously your doctorate from the University of California Institute of Technology in 2012. And you received your master's from the Arizona University. And there's some interesting postdoctoral experience that I would love to discuss. But why don't you share with us, if you could, what made you, your title is structural geologist, if I'm correct,
yeah.
Right? So could you share with us what made you, I don't know if it was a life-changing moment or if it was a slow process that kind of made you get there, but...
I as an undergraduate at the University of Minnesota, I didn't really know what my major would be. And my father was an electrical engineer. So I figured I would be an engineer because I was okay at math. And then I took an introductory geology course after a couple of years, and I realized this is good stuff. Like I can get a degree and like go on camping trips, and that's going to count towards my degree. So I thought that was pretty great. And also I noticed that geologists were doing a lot of traveling, and I thought that would be interesting to sort of have, go to these interesting places around the world as part of my career. So I switched over after I think about my third year, and structural geology just sort of seemed like one of the things that I was most interested in. It's a topic that's pretty accessible to a lot of undergrads. Sort of gravitate towards structural geology because it deals with folded rocks and faults, and there's lots of field trips and hands-on stuff.
So these expeditions that you envisioned, how soon were they realized after your decision?
Oh, even the first course had field trips to, a Saturday field trip.
I see.
And then a lot of the other courses as well would have maybe a weekend trip or summer field camp where we went to Montana or Colorado for a few weeks.
So the great outdoors. I don't know, maybe you can comment a little bit on what is the distinction between geology and other sciences, especially as it comes to doing laboratory time and exercise, because I know physics and chemistry can be very successful in the lab, but how much can you do in the lab as opposed to outdoors to make progress in this thing?
The geosciences covers the whole realm. So there's entirely field-based geologists and there's entirely lab-based people as well. So there's the sub-branches of geochemistry, geophysics, and those can be very theoretical, or in the case of geochemistry, very analytical, where you're entirely doing laboratory work, measuring isotope ratios and that kind of thing. Personally, I do a lot of work. I do a lot of microstructural work, so I spend a lot of time using the scanning electron microscope or the optical microscope, looking at little what we call thin sections of rocks, so basically shavings of rocks that are thin enough that they're transparent, and sort of finding out as much as you can about the history of the rocks from that.
So you bring these samples in the lab from someplace outdoors.
Right.
So I assume that through your research, and you already alluded to that, you have to actually go there and collect them yourself, right?
Sometimes go there and collect them. Other times that work's been done. So I had a postdoc in New Zealand, and they've been collecting all the samples from their students over the years. So there was this library of samples in the basement, and so I collected a few, but I took advantage of that. It would have taken 20 years to collect all the samples that I used.
I see.
Yeah.
So then I wonder if there's any specific industries that perhaps you envy for their access or resources to good samples. Would you have anything at the top of the list for that? Or?
Well, for the work that I'm doing, it's not. So if you're kind of in sedimentary or more shallow structural work, then the seismic the oil companies have great data, three-dimensional data sets that are phenomenal. I kind of focus on things that are a little bit deeper, sort of 10, 20 miles down, and so there's not really any way to get down there. And the oil company, it's too far down for the mining or petroleum industries to be interested in it. So
I would like us to return a little bit later in terms of the industries and the applications of this science. However, I also want to ask you about the scale. We already covered different scales, I think, but you talked about the samples, the thin sections you're using and analyzing in the lab, and then you extrapolate or arrive to some conclusions that go how deep?
Oh, well, the work I've personally been involved with is probably the best example of that is some experimental deformation that I did. So I did some lab work where we took samples that were sort of about 1 centimeter in size, and we heated them up in a special machine to about 1,000 degrees under high pressure and squashed them. So they were quartzite samples, and it took generally a couple days. And those types of experiments are used to predict how strong the crust is, so at the hundreds of kilometers scale. So that's sort of the we can measure the rates of movement of the crust from GPS measurements oftentimes. So we have some idea of that, but to sort of get at that, what's happening in the deeper parts where it's not just blocks sliding past each other on faults, but actually kind of slow oozing of the rocks over time. Getting at that, those experiments are one of the sort of best ways to approximate that information.
I understand. Of course, that's in relation to our limitations in digging down there, right? I mean, I don't know what's the deepest. I've heard stories about the mine and the deepest mine and the deepest, these trivial facts of.
Yeah, the deepest hole, I think, is something like 10 kilometers or 10 miles or so.
And then there's this is some kind of a well.
That's a drill.
A drill,
yeah.
I see.
Yeah, they drilled.
And the mine, if I recall correctly, it's someplace in South Africa or something, that it is just... so there are limitations that in your discipline you're trying to overcome by simulating, if that's the right word.
Yeah.
Simulating these conditions in the lab, using the appropriate samples. Very well. So if you would elaborate a little bit on New Zealand, is that the furthest you've been from home? Doing this? Okay. And this was on a fellowship from the National Science Foundation?
That's right. Yeah. So as a doctoral student, you see the end of your time approaching, and you have to figure out, okay, what am I going to do?
Sounds pretty ominous.
Yeah, I got to apply for some jobs, or one of the most common things is a postdoc. So I wrote a proposal for a project in New Zealand to work with some people there and do some very specific thing, and it was funded. So I spent 1.5 years there.
I assume that anything that has to do with anything from the National Science Foundation is extremely competitive these days, so it's a big achievement of yours.
It was an honor, yeah. I think that the odds were sort of on the 30 or 40% were funded. So not as bad as I thought.
Yeah, that sounds higher than I think what, the proposals for funding may go for. And so if we come back a little bit to the industries, I know that students who are coming in as undergrads, it's the typical question, maybe the first question. I love doing this. What type of job I can find after I'm done with this? What would you have to offer to them?
I haven't. There's a variety of things, and they're generally the students find employment in. There's the oil industry. There's a lot of environmental and consulting work. You can become a state geologist. The academic jobs, and I think a fair number of students go in different directions, teaching at different levels. So something I read once about geologists in particular was in World War II, I believe that they were really sought after because they're used to dealing with, in the war effort, they're used to dealing with messy information, like messy data. So I mentioned how there's geophysics and geochemistry, and so you as a geologist, you're using a really wide range of tools and information. You have to sort of synthesize that kind of thing. So you can be pretty flexible after your degree, I think.
I want to ask you, Steve, about your experience interacting with students here at City College of New York. I don't know how you feel about the bedrock that we're located on. For you would know probably more than the rest of the occupants in the science building combined about that, but we're situated here in Manhattan, and we have qualified students, undergrads and graduates. You are the graduate advisor for the Department of Earth and Atmospheric Science. So what has been your experience in terms of projects and working with students so far?
Well, a lot of the undergrads are interested in research projects, and I've worked with a few, and my other colleagues have as well. Typically, I'm working with one or two at any given time, and so I also have a master's and PhD student now who are both working on projects related to New Zealand. So I got a grant funded to do some work in New Zealand. And so one of my students is actually spending the semester at Brown University doing those rock squeezing experiments that I mentioned.
Oh, rock squeezing?
Yeah, that's what we call it. That's the technical term. And my other student is working on starting a project, my master's student, on some xenoliths. So xenoliths are chunks of rock that have been carried up in a volcano in New Zealand, and they're actually chunks of the mantle. So they're at least 30 miles down, and they're green. They look totally different than the rocks we normally see at the surface. And so she's trying to figure out sort of what the stress levels are there and how fast the rocks are moving, and try to understand better what's going on below the crust in terms of the deformation.
The green would be olivine in this case?
Yeah, the mineral olivine. And there's some pyroxene in there as well. And you mentioned the City College is sitting on the Manhattan schist, which is, as you guess, is a great rock. It is, it's pretty. It's got garnet, coarse grains of mica. So there's some muscovite and biotite that are kind of flake off and nice to look at. And it's been very highly deformed. As a structural geologist, it's a pretty great rock. You can see, if you look carefully, you can see where a layer will sort of come like this and then be folded and then come back again. And so they've been extensively squashed, to use that term again. So it's a lot of fun. So I take my undergrad structure class. We'll go out and look at those rocks for a few different Friday afternoon labs, and they learn to use we need to take measurements with a compass, so we go out there and learn how to use the compass, and then we look at those rocks.
And the traditional compass is still the better way of doing this, because I have seen these applications on iPhones and I'm not entirely convinced they're accurate. I tried them out, but I was not successful so far.
Different strokes for different folks, I think. I like the traditional compass it's tried and true. It's not going to run out of batteries. It's got a little mirror in it, so you can kind of see your reflection if you want to. You can check your teeth after lunch.
Makeup.
Yeah. No, it's a really great instrument. So we train the students to use that, and they're welcome to bring their phones and try that as well. It seems like you need the apps that you just download, that they're not super reliable. So you may have to do some kind of calibration or something before you would want to collect a lot of data with your phone. But it's definitely, my colleagues are doing that, and I'm on a listserv where I hear a lot of discussion about training the field camp with the iPads and that kind of thing. So it's happening.
I see. Speaking of the difference between traditional approaches and modern approaches in equipment, in this case in technology, I was wondering what's the current trend in your perspective in terms of professional growth in this field for, say, entry-level students who are graduating with enough structural geology background. Mm-hmm. What would be the industries that may employ them?
Well, the obvious one is the oil industry. So a lot of oil, where you find oil is controlled by structures, basically. So you find, if the rocks are layered like this, the oil tends to rise up into that. So structural geologists, if the industry is going well, if the gas prices are high, then there's always jobs for geologists there. But there's actually a lot of other directions or other employment opportunities. There's a lot of consulting jobs out there. Our students often have GIS background, and there's a lot of sort of government jobs and other consulting jobs where there's a lot of GIS work to do, and environmental consulting jobs as well. So the geologists tend to be pretty trained in a wide variety of fields. So you'll take a geophysics class, and you'll take a geochemistry class, and an aquatic chemistry class. So you have a really broad background coming out of the Earth Science program. So we are the Earth Science department, used to be Geology department. So I think that background is actually pretty. Our students find jobs. Some end up teaching at different levels, college level, high school.
Sounds great. Sounds promising. And I have to disclose a little bit of bias here because I work for the same department, and this way I'm biased in favor of what you're saying. I could not agree more, but there it is, the disclosure. So we have been talking to Professor Stephen Kidder of the Department of Earth and Atmospheric Sciences. Professor Kidder is assistant professor here at City College of New York. I would like to thank our host institution, which is City College of New York, and specifically for this interview, the radio station WHCR 90.3 FM, the Voice of Harlem, and the general director, the general manager, Angela Harden, as well as Christopher Fiore, who is responsible for videotaping all of this. My name is Angelo Lampousis. Professor Kidder, Steve, thank you so much for being here.
It was a pleasure.